Most direct input devices use an absolute mapping in which the system cursor is positioned directly under a finger or stylus. An absolute mapping is fine on a small display when all areas are easily within reach, but on a large display this is not the case. If a user has to frequently stretch or walk to reach targets, an absolute mapping becomes tiring and inefficient. However, by using a relative mapping between pen and cursor, distant targets can easily be reached. But when targets are nearby, the strong affordance for direct touch makes relative pointing less natural. We have developed a hybrid technique that allows the user to fluidly switch between relative and absolute input depending on the pointing task at hand. We use a high-resolution 16 by 6 foot display and a custom-built pen tracked by a commercial motion capture system. Our pen provides very accurate position and hover distance information and includes a tip switch for pressure-based clicking. Before demonstrating our hybrid technique, we first explain relative input in more detail. The relative movement of the cursor is accelerated through a function that adjusts control display gain based on pen velocity. This provides fine control with slow pen movements, yet enables the cursor to be sent across the display with a fast movement. Clutching is accomplished by simply lifting the pen off the display surface. The default state for the hybrid technique is absolute mode. Note the circle that floats near the pen but avoids getting too close. We call this a trailing widget. Its viscous dynamics keep it out of the way when pointing at targets, yet a quick deliberate movement can trap it. The trailing widget is used to switch from absolute to relative mode. When the widget is trapped, the circle shrinks and moves under the pen tip. At the same time, the cursor is disconnected from the pen and we're in relative mode. To return to absolute mode, the pen is lifted past a hover threshold. Note how the circle is released from the pen. We found this method of switching between relative and absolute to be quite natural and fast. However, we also found that when the cursor was near the pen in relative mode, users naturally reached out to grab it. So we also support the secondary relative to absolute switching method. We implemented several means of visual and auditory feedback. To communicate pen distance, the cursor fades out when the pen is off the surface and dangles if the pen is far away. When in relative mode, we display a partial line between the pen and the cursor. This reminds the user what mode they're in, and the length and direction of the line also helps locate the cursor. We use animated transitions and play a sound to reinforce the switch from absolute to relative, and back to absolute again.